In example 3, we have a word problem involving direct variation. We are told that the weight of a load of bricks varies directly with the number of bricks in the load. So let's let W equal the weight and B equal the number of bricks. Translating that sentence, the weight varies directly, that's equals K times the number of bricks. And now we know that a load of 40 bricks, so that would be the number of bricks, is equal to a weight of 92 pounds. And that will allow us to solve for the constant of variation K. So dividing by 40, we get 92/40 is equal to K. Let's take and reduce that. So our K value is, dividing by 4, that would give us 23/10. Now, our equation of variation is W is equal to 23/10 times B, where W is the weight and B is the number of bricks. That is something that we can now use to find the weight for a load of 50 bricks. So if the number of bricks is 50, we can do this multiplication and find out that the weight is 50 divided by 10 is 5 times 23 would be 115 pounds. Make sure to put units on your final answer. All right, try the next one on your own. Ticket prices at a concert are inversely proportional to the distance from the stage. Seats 10 feet from the stage cost $200. Find the price of the ticket 50 feet from the stage. Pause the video while you try this one on your own. Here's my solution. I let P equal the number of the price of the ticket and D be the distance from the stage. This time we have an inverse proportion, so P is equal to K divided by D, and we can insert the information that a distance of 10 feet from the stage gives you a price of 200. Multiplying by 10, we get a K value of 2,000, and then we can rewrite our equation of variation, input the distance of 50 feet, and do the division to find $40 as the price of the ticket. All right, now we're going to explore something called combined variation. When Y varies jointly, that is a direct variation, but with two variables. So we have Y dependent not just upon one variable, but on the product of those two variables. So Y is equal to K times A times B. And these are used when we have a number or a variable that's dependent upon more than one other variable. And another example of combined variation is Y varies directly as A and also inversely as B. So we write a combined variation equation. Y equals K times A, that's our direct variation, divided by B, that's our inverse variation. This can be extended to more than just two variables. All right, let's take a look at our equations of variations in example 4. The lateral surface area, which we're going to call S, varies jointly as its radius R and its height H. So S varies jointly as R and H. So that means that S is equal to K times R times H. And they're not asking us to find the variation constant, just to write the initial equation of variation. In B, the area A of a regular polygon varies jointly as its apothem and perimeter. So area varies jointly, so equals K times the apothem times the perimeter. All right, let's take a look at example 5. For each of the following, find the constant of variation. the variation equation and then use the equation of variation to answer the question. This is important that we give all of those answers, so we're going to recognize when we get each one of them. So we're going to start with example 5a. P varies directly as t and inversely as the square root of v. So let's start by translating that. P varies directly equals k times the variable t, but inversely, so that means we're going to divide by the square root of v. Make sure that you know the difference between square and square root. So that's our initial equation of variation, and we have some given information. P is equal to 10 when t is equal to 2 and v is 9. That's going to allow us to find the equation of variation. So P is 10 whenever t is 2 and v is 9. So substitute all those values in. That gives us 10 is equal to 2k divided by 3. And if we multiply both sides by 3 to clear the fractions, 30 is equal to 2k and k is equal to 15. So that means that that's our constant of variation. And that's the first answer that they've asked for. The second thing that they've asked for is the equation that relates the variables. So that would be P equals 15t divided by the square root of v. That's our equation of variation. And that has to be the equation that we write initially, but with the value of k inserted. And then there's finally the answer to the question, which is to find P whenever t is equal to 10 and v is equal to 25. So I just took that equation and I replaced the t with 2 and the v with 25. Now we just need to simplify. That's 150 divided by 5, which is 30, is the value of P, and that's the answer to the question. So we have three answers. We have the constant of variation, the equation of variation, which is the equation with that constant inserted, and then finally the value that was asked for. All right, try the next one on your own. Pause the video while you do this. All right, here is the final result for this one. Notice that we have three things to report as answers. Number one, the constant of variation. Number two, the equation of variation, and then the final answer that's asked for. In example 6, we're writing an equation to represent the problem situation and then use it to answer each question. This is very similar to the ones we've just done. The volume of a gas in a given mass varies directly with its absolute temperature and inversely as its pressure. Let's stop and write that equation. Let's let V equal the volume of the gas and T equal the absolute temperature and P equal the pressure. So the volume V varies directly as the absolute temperature. So that would be V is equal to K times the absolute temperature, and inversely as its pressure. So that means that we're going to divide by the pressure. All right, at 300 kelvins, that would be the absolute temperature. So I'm going to insert that into my equation here. And at a pressure of 100 kilopascals, so that's going to be our pressure. The sample gas occupies 24 cubic centimeters of space. So 24 cubic centimeters would be our volume. We're going to find the volume if the temperature is increased to 400 kelvins and the pressure is decreased to 50 kilopascals. So we've already got some information inserted into our equation. We can simplify here. 300 divided by 100 is 3. So 3K is equal to 24, which gives us a K value of 8. So that's our constant of variation. And that means that our equation of variation is V is equal to 8 times T divided by P. Once we have that equation of variation, we can substitute the new information into that. We're increasing the temperature to 400 kelvins, so that would be the value of T, and then the pressure is decreased to 50 kilopascals. So the volume would be 8 times 400 divided by 50. I think I'm going to reduce here before I multiply. So 400 divided by 50 is 8. So that's going to give us 8 times 8 is 64. Now we have to put units on that. That is a volume, and the other volume was measured in cubic centimeters. So volume is 64 cubic centimeters. In the last example, the maximum weight that a circular column can support is directly proportional to the fourth power of its diameter and inversely proportional to the square of its height. Let's take a moment and write all this down using variables. So maximum weight, we've got diameter and we've got height. So let's let maximum weight be W. And D be diameter, and H be the height. So the maximum weight that a circular column can support is directly proportional to, so that means equals K times, the fourth power of the diameter, so that would be D to the fourth power, and inversely proportional, so divided by the square of its height, so that would be divided by H squared. So a 2-meter diameter column, so that means we're going to insert 2 in the place of the diameter, and then that it's 8 meters in height, so we'll insert 8 in the place of the height, can support 1 ton. So I'm going to replace that W there with a 1. All right, let's use that information to find the constant of variation. 2 to the fourth power is 16. 8 squared is 64. So if we multiply through by 64, we get 64 is equal to 16 times K. Dividing by 16, K is equal to 4. That's our constant of variation. So now our equation can be rewritten inserting the constant of variation. So W is equal to 4 times D to the fourth divided by H squared. So just take that equation we initially wrote and insert the constant of variation. And so we are finding the weight, so that means we don't know that a 1 meter diameter column, so we're going to replace the D with 1, that is 4 meters in height can support, so replace the H with 4. So we have 4 times 1 to the fourth, which is 4 times 1, or 4, divided by 4 squared, which is 16. So W is equal to 1/4, and W is that maximum weight. Let's take a look at what our maximum weight was measured in before. Maximum weight was measured in tons before, so that would be 1/4 of a ton. That's it for the lesson.